discussion until the end of the talk. Okay, go ahead.
Okay. All right. So what I'd like to discuss, back to some basics. What is a requirement? Because it turns out that that's not really apparently settled. Why do we have requirements? And then I want to talk about uncertain, potential, invalidated requirements, because I know the first two terms I've seen recently in the materials that I've been reviewing on adaptive things. Then I want to talk a little bit about it. What would adaptable requirements development actually be given what we've just been through? I published some measurement capability, and it turned out we had identified adaptability as a measurement in some of our architecture work a decade ago. So I'll mention that and point to some papers there, and then we can have whatever discussion, and you can correct me on any of my misunderstandings. I will be referencing a number of papers from INCOSE, mostly mine. These are free access for INCOSE members in the online library that you can get to through the INCOSE website. And as I said, all the presentations from my prior papers are available on the YouTube channel. What is a requirement? The first time I presented roughly this slide was 2004. When I wrote the requirements, first requirement, second requirements completeness paper. I was puzzled to hear from some of the members of the requirements working group that they didn't consider requirement mandatory. I thought we had settled that at least in INCOSE in 1993 in a paper by Rick Harwell and a few others. And I thought this was a good description. If it mandates that something must be accomplished, transformed, produced, or provided, it is a requirement, period. Which suggests if it doesn't mandate something, it's not a requirement. And I looked up in the dictionary to see, well, what does the dictionary say a requirement is? By golly, something that is required, a necessity, obligatory. So that kind of fits with the way we were using this term. And I point out that means it's not a design description, a goal, desire, or something else. It's absolutely necessary. And therefore, phrases like tradable requirement that's an oxymoron, because if it's tradable, that means it's not actually required. I did say we typically in our sets of requirements have some sort of designated word that indicates that something's mandatory. And there's lots of argument in industry and government about what the proper word is, and I don't want to get into that, but some designated word should indicate that something's mandatory. And I pointed out that if we don't have the idea of mandatory, then concepts like completeness are impossible, because there's no end of potential or desirable or goal or design description kinds of requirements. So this slide in particular was in the context of the paper I was giving at the time, 2004, regarding definition and how you implement or achieve completeness of a set of requirements. So why do we have requirements? Well, they come from the contract, acquirer-supplier kind of relationship. They provide the basis for the technical contract, defining the expectations and what I like to call the acceptance criteria, but that's if and only if they're actually mandatory. And they provide a verifiable means to ensure that the as-delivered system or system elements satisfy the technical contract. So it's very clear why they're useful. And this is another reason why I think that even though a lot of folks are interested in model-based contracting, I'm not optimistic that that's actually going to replace text-based requirements, because contracts tend to be written with text, and establishing requirements in models as part of a contract, it's been talked about for a while, and maybe some folks are trying it, and I think there's probably a few things that are going to need to be worked out. I'll note that the absence of requirements means that there really is no basis for evaluation and assessment in a objective sense other than the user and stakeholder feedback, which, that's the essence of Agile. And I discussed this in a 2013 paper a long time ago, Can Systems Engineering Be Agile, and pointed out conditions under which you might consider Agile kind of methodologies, but they were largely going to be foreign to hardware and systems, especially when hardware have long development or build cycles. Since I wasn't really familiar with your area, I decided I'd take advantage of some AI tools. So I invoked Google Gemini AI tool and asked what's meant by uncertain versus potential requirements. This is actually the second question I asked, but first one here in the slides, because I wanted to know what it could find in the way of industry information. And it was kind of what I expected. Need or function is known, or might be some known, but there are details that are unknown. And so the goal here would then be to resolve the ambiguity and clarify the requirement. And that makes perfect sense to me based on the word uncertain. Potential requirements may have some degree of refinement compared with uncertain, but they lack, as it says, a confirmed need for that specific capability. So what we don't know is whether it's actually necessary or when in an implementation cycle it might be become necessary, thus a requirement. So the goal here would be to monitor and decide whether to make it a confirmed requirement. So that's what Google Gemini told me about these two terms. And I thought I can understand those. I think they make sense. Nobody in this working group has validated that Google Gemini knows what it's talking about, but that's what I discovered. So if I try and put these things together, then I can come up with some taxonomy for these different terms that I think would apply to adaptable development. Requirements are mandatory characteristics that are validated, and I did a paper 7 years ago with a colleague from Boeing for validation criteria, that they are verifiable, meaning they could be proved to be satisfied or not based on some method like testing or analysis, but they have quantitative success criteria and so forth. They are indeed necessary. They are sufficient to satisfy the parent need or requirement, and they are feasible. And these characteristics, validation criteria, subsume the ones in the INCOSE literature, the Guide to Writing Requirements, and the INCOSE SE Handbook. And this paper shows the mapping. But these are the characteristics we came up with and started using within our company to know that we had valid requirements, not just English statements with a shall in them. If I make a little diagram, then uncertain requirements based on the description may not be verifiable, necessary, sufficient, or feasible, because if they're not completely well written, it's hard to tell if they're not verifiable. And if they're not verifiable, it's really hard to determine the other characteristics because you lack the quantitative and observable information about them to make those determinations. I place potential requirements as partially validated. They may be well posed. They might be sufficient to some stated need. You may be able to determine feasibility, but you haven't determined yet that they are necessary. So the process of getting any one of these categories moved over into requirements is they have to be validated. That may require some rework to fill in the blanks for uncertain elements of the requirements, or clearly establish the need, thus satisfy the necessity criterion with respect to validation. So that's, in my mind, what it takes to move from those two categories of requirements to have what I call requirements, or quote validated requirements. And I hate having to use the prefix, because to me a good requirement should be validated. And again, I want to reiterate, we shouldn't call something a requirement if it's not mandatory. So I'm still a little bit uncomfortable calling these things potential requirements, but that prefix or that adjective clearly indicates you don't know that it's yet mandatory. I asked Google Gemini another question. This is actually the first question I asked it. So what do you mean by, what is meant by adaptable requirements development? Because I was sort of a newbie in this area and I wanted to discover what it could find in the literature. And this seems to be consistent with what I've been reading. An approach to defining and managing project requirements prioritizes flexibility, continuous learning, and responsiveness to change over rigid upfront planning. That sounds like what I've been hearing for a while about sequential versus agile development. It recognizes that in complex or dynamic environments, particularly software development, where is often referred to as adaptive software development, or a core aspect of agile methodologies, and this is my emphasis, requirements are likely to change as the project progresses, stakeholders provide feedback, and new information emerges. And that's exactly what's in the INCOSE SE handbook about agile methods. So I'm wondering if one of the outcomes of your work group activity may be emerging with the Agile working group. So I'm not sure. Maybe we'll have that discussion later. So what might we mean given those descriptions about adaptable requirements development? We don't know all the requirements when we begin architecture, design, and implementation. So in the INCOSE SE handbook, the current edition, 5th edition, there's a graphic in figure 2.5 about evolutionary development. And the description is you don't know all the requirements when you start. So it's got initial, partial, and then you design and build and deploy and learn and develop additional requirements, and you design and build and deploy and learn, and more requirements come out of the learning. So you design and build and deploy and learn and so forth. So it's a continuous process of define, build, use, and evaluate, and then do some more of that. And this is, in my mind, is the essence of agile methodology. You didn't know everything up front, but you want to create something that can be experimented with or used in order to find out what else might be required, so you can implement that in some future cycle. And I noted in my 2013 paper that agile development really is a finish to finish kind of set of activities for most of the system engineering activities. So if we look at the left side of the V, requirements and design, then the bottom of the V is build, then the right side is integrate and verify, and continuous validation. Really the only required sequence is that you can't integrate something you haven't built, but everything else can be done asynchronously, and maybe you don't even need verification, but it's very responsive. It's intended to be responsive to stakeholders, and that's why validation is so important. Have we built something that's useful with respect to the various stakeholders? But all the documentation can happen after you have something that is deemed worthwhile and valuable. So that's why I call it agile methodology, more of a finish to finish kind of thing. It doesn't demand the sequences of hardware or system development, because often the same people are doing the build as are doing the design or writing the requirements. And the whole point of agile is to get something built and integrated so that a user or other stakeholder can evaluate it and provide feedback. So that's what this looks like to me. I thought I ought to, so process-wise, then it's a modification, not a throwing out, but a slightly different implementation of the processes that are in ISO 15288 and the INCOSE System Engineering Handbook, and the paragraph numbering is identical in both. You collect up the stakeholder needs, refine, deconflict, and prioritize needs into stakeholder requirements, and validate some subset of those for some initial implementation, and those would be called system requirements in the ISO standard. And we would form them as well-posed structured requirements, and I'll show that on the next slide. And then we proceed through this development cycle: architecture, design, implementation, integration, maybe verification, but not necessarily, and validation. And we can measure things along the way, and I'll show my adaptability architecture metric on the next slide. But once we've put it into use for validation, then we can revisit the stakeholder needs, do a gap analysis between what we have and what now the stakeholders say they want, validate additional requirements and add those to the baseline, and repeat the cycle: back architect, design, implement, and so forth, as many times as is necessary until we run out of gaps. And that's the way this kind of looks to me. It's not really a different process. It's using and tailoring the processes defined in 15288 in the INCOSE SE handbook, but changing perhaps the order or adding significant loopbacks so that we can add or modify requirements and proceed through the process again. One of the reasons the basic construct in 15288 is the way it is because we want to avoid large feedback loops. But in some industries or some domains, especially with software, those aren't so onerous and burdensome, and you can take advantage of the fact that you can do build and implementation cycles very quickly. And so you really have the freedom not to have to design everything up front, because you get more than a single chance to get it right. So characteristics, we would still have controlled change using the configuration management processes. We should have traceability of the source of the change based on feedback from the stakeholders, which leads to revised stakeholder needs and so forth. And this overall process would be quite suitable for time and materials kind of contracting. I wouldn't recommend it for firm fixed price contracting because you really don't know what the desired end state is. But any individual iteration might be amenable to firm fixed price. You've got a validated set of requirements, so you know what the required end state is. So that might work okay in that situation. I mentioned that I was going to show you what I meant by well-posed requirements. So this is originally from my 2015 paper. Requirement structure that helps us get verifiable requirements, standard format of the who, shall, what, how well, under what conditions. And we'd filed a couple patents showing how we could implement that with a few different types of requirements. So functional performance requirements have well-defined fields for the who, the what, the how well, and the under what conditions. And that works pretty well. We implemented this in some automated requirements management tools and capabilities. This is what we taught in our internal courses. This is represented now in the INCOSE Guide to Writing Requirements. Appendix C has these 4 patterns. So this is the functional performance type. We have a design requirement type that again is verifiable, but the exact content, the specific fields might be different, not require actually a performance attribute because there's some observable design constraint like materials, for example. There may be condition statements like if you have a performance attribute associated with weight, then you need to know whether it's dry weight or empty weight or fueled weight or whatever, those kinds of considerations. Another type is environmental requirements. What are the environments to which the entity is going to be exposed to, and what is its required behavior or characteristic during and after that exposure? And the last type is a large category called suitability, which are the non-mission essential characteristics having to do with fitness for purpose, like reliability, safety, and so forth. So these were 4 templates we put together and started training our engineers to use one of these for every requirement and then structure each of the requirement statements to match. I mentioned adaptability measures. We did a couple of papers on architecture measurement. The first one I did with Paul Cole of Lockheed in response to a industry committee request. The second one I attempted to apply it, but most of this table is present in both of the papers. We had identified several measurements for architecture. One of them was in the category quality of solution, and these were the some of the non-requirement attributes that our sponsors seemed to indicate were important, but they weren't necessarily requirements. So we lumped them into a category called suitability. So it includes anything ending in ITY and a few other things. And we did have adaptability in here. And the scale on all of these and the result is a 0 to 1, as in Haifeng's paper, one of his papers. It's INCOSE 2016. And for things that do have thresholds, then the suitability attribute is a measurement of the degree to which you exceed the threshold. So if you meet the threshold, then the performance attribute would be 0. But if you can exceed it towards some objective, then you can get credit. So this was a way of including value considerations for preferences that weren't actually threshold kinds of requirements. So this is another way of making selections when it's not a firm number, but there clearly is value in some of the preferences. So this is what we'd published beginning in 2013 about adaptability measures with respect to architecture. And I don't think we defined what this was, but it was understood in our discussions to be something that might be desirable. Perhaps flexibility might be changed to agility right now, but this is what we published back in the day. So that's what I wanted to mention. Sorry, I went a little over time because I know we wanted to limit this to 20 minutes, but here's a list of the papers and sources I referenced. All the INCOSE papers are available through here. You can download them free if you're an INCOSE member and you sign into the INCOSE website, then you can get to the library and download papers. Then the INCOSE SE handbook, which is also downloadable from the INCOSE store. ISO 15288, yeah, you got to purchase that. And the INCOSE Guide to Writing Requirements is also available in the INCOSE store free for INCOSE members. With that, I'll be quiet and entertain your thoughts and questions and learn from you. Thank you very much.
Well, all right. So we're certainly open to questions.